All right, Big Ideas Algebra 2, Section 9.3, trig functions of any angle. So we're going to be able to evaluate trig functions of any angle, not just of the common ones like 30, 45, and 60, 90, of any angle in between those. But then we're going to also use reference angles to kind of compare and contrast some two different trig ratios. So within each circle, you can create any right triangle using the radius of the hypotenuse to match up with your right triangle. So this blue line that is going to this unknown point of xy, the distance from the origin to the point on the circle is known as the radius, and then the theta is known as your angle of reference. And the coordinate points that you get for your xy, you're going the x distance along this base of the right triangle, and then the vertical moving up towards that point to get your y. And it can be found by using your a squared b squared plus equals c squared, which is where this x squared plus y squared equals r squared comes from, implementing on the parts of the circle. So continuing with your trig ratios of using SOHCAHTOA, the sine of your angle is equal to opposite over hypotenuse, and your r is your hypotenuse, the y is your opposite. Cosine is x over r, tangent is y over x, and then each one of your reciprocal functions of cosecant, secant, and cotangent are just flipped. So these functions are also known as circular functions because you're putting this right triangle on this circle. So assuming that you have a given point of -4, 3 as the terminal side of your angle theta, what would be the six trig functions of your angle theta? So we're going to use Pythagorean's theorem to find the length of our r. We have -4 as our x, and y is 3. Plug that into your a squared plus b squared equals c squared formula to get the square root of 25, which is 5. Your r is always going to be a positive distance because you're squaring numbers and then you're taking the square root. If you ever get a negative for your radius, you're doing something wrong. So using those three values, plugging them into your 6 trig functions, you take y over r, which is just 3 over 5. Cosine is x over r, which is -4 over 5. Tangent, y over x is -3 over 4. Then the next three, you're just taking the reciprocals or flipping them. And those are your values for all 6 trig functions. So incorporating this into a unit circle, a more specific type of circle that you can use with your right triangles, if your radius is equal to 1, and that is never going to change, all of your x and your y values can be easily figured out with your trig ratios along this unit circle. Because your x squared plus y squared is going to equal to your radius of 1, assuming that you're starting at the center of 0, 0, the values of your sine and your cosine are pretty simple x and y coordinates wherever you're going to line up on your unit circle. So remember, we talked about this in the last section. These are the degrees and the radians that we're going to be using within our unit circle, just taking kind of your radius of 1 along the outside. So the distance from the center to any other point on the outside of the circle is equal to 1. So using a reference angle of 5 pi over 3 and -130 degrees, using the terminal side to determine which quadrant you're going to lie in, again, based on where these values are going to be. So 5 pi over 3 is down here, which is in the 4th quadrant. So you're going to take your 2 pi, which is going to be the next radian measure to the line between your 2 quadrants, subtract them, and then you get your pi over 3. For -130, for your coterminal side, you're going to be adding 360 to get to your 230. That terminal side is going to lie on the 3rd quadrant. So to get to the next x-axis side, you would get to 180, so you take the difference and it would be 50. So that would be the reference angle, would be 50 degrees. So there's kind of some more examples of how you would take your reference angles to kind of find the next the next one over or the next one back, depending on what quadrant you are in order to get to your first quadrant. Everything you're going to be looking at is going to be between 90 and 360 degrees. And then in radians, it's pi over 2 to 2 pi. So a lot of it is just adding or subtracting 180 or 360, depending on which quadrant you're in, and then pi or 2 pi, depending on what quadrant you're in. So if it's in the first quadrant, there's no other reference angle that you need. But if it's quadrants 2, 3, or 4, these are the formulas you're going to use, whether it's degrees or radians. So let's use the unit circle to evaluate 6 trig functions of our theta 270. So 270 degrees is in between quadrants 3 and 4. It's actually on the negative y-axis for your terminal side, and the coordinate point is going to be 0, -1 on your circle. So we need to identify the point where that terminal side intersects with the circle. Then we need to find the values of our 6 trig functions where x is 0 and y is -1. Notice that your radius is always 1, so this is what you're going to be plugging in for each of your values. So the sine of theta is equal to -1, so the sine of 270 is -1. Cosine, still using 1 as our radius because 1 is always the radius of our unit circle. And then there's your tangent. Notice how your tangent is an undefined value. You cannot divide by 0, so there is no tangent of 270. Or there is one, it's just not defined, or it's in infinity. Cosecant, you would just take the reciprocal and flip. Secant, again, same thing, take the reciprocal and flip, and look, when you're dividing by 0, you get undefined. Cotangent, you now get a value because you're flipping the 0 back up on top to get 0. All right, so a couple different helpful tips to help you evaluate depending on which trig functions you're doing in the quadrants. So quadrant 1, every value is going to be positive because it's positive x, positive y, and whenever you're dividing positive by positive, you're always going to get a positive. Then the values start to change depending on whether your negative is part of your x, part of your y, or part of your radius. So if you just want to go through each one by one and just kind of methodically divide your positives and negatives, you're still going to get these numbers. But if you like to look back as a reference point to double check, hey, in quadrant 2, my cosine should be negative because my negative x divided by a positive radius gives me a negative value. So this is where you're getting the final values as kind of a checkpoint for whether you're using the correct signs in all of your trig functions. So let's evaluate some specific trig angles. So -240 is coterminal with 120 degrees. You're adding or subtracting 360, and you're getting back to something that is a little bit better of a reference point. So you would take away 180 minus 120 to get your 60 back into the quadrant 1 per se. And since it is in quadrant 2, the tangent function is going to be negative. So the tangent of 60 is going to be -√3. When you look back at the unit circle, which I believe was the next one right here. So we're looking at our 60. So the tangent of that value, when you would plug that in normally, is going to give you √3. But when you're looking at depending on whether your -240 is actually in the second quadrant, you need to follow those rules of your tangent being a negative value. 17 pi over 6, again, you're going to use your coterminals by subtracting 2 pi until you get it within a value of 0 or 2 pi, because it can rotate an infinite number of times, but using our reference angles to get coterminal with 5 pi over 6. Then to get it back into the first quadrant, you're going to take 1 pi minus 5 pi over 6 to get pi over 6. You can find your common denominators. This is 6 over 6. 6 minus 5 is 1. And your cosecant of that is positive in the second quadrant based on the previous slide. So the cosecant of pi over 6 is equal to 2. All right, using a real life problem. So the horizontal distance in feet traveled by a projectile launched at a specific angle with an initial speed is this formula. It's not something that you have to memorize. It's going to be given to you in any other problem that you work through. So don't worry about memorizing this formula, but it's just the model for what horizontal distance is based on your launch angle. We're going to estimate what the horizontal distance in feet is going to be by a golf ball that is hit at an angle of 50 degrees and an initial speed of 105 feet per second. So our given angle, a launch angle, is 50 degrees, and the initial speed is 105 feet per second. So those are the values that we're going to plug in. V is our initial speed, which is 105, goes in the V position, and then 50 goes in your theta angle. And you can just type these in a calculator. So you're going to take 2 times 50, and then 105 squared, take sine of 100, and then use PEMDAS to get that all the way down to 339 horizontal distance in feet.